2.4 is measures of central tendency and variations. There's two kind of overall things we're going to talk about in this section. The first one is called measures of central tendency. And there are three measures of central tendency. The statistics course before, you've seen these. Most of these are introduced these days in early middle schools and as late elementary school. This is a concept that you teach in that age range you're probably going to encounter. I know they weren't taught when I was there, but they are taught there now. And so the mean is the arithmetic mean. It's the average of the values found by adding the values together and dividing by the number of values. So if I want to find out the class average on a test, what I do is I add all your numbers together and I divide by 6 if there's 6 people in the class. Okay? So that's how we find averages. So when you say average, most likely this is what you're talking about. This is the one people mean when they talk about an average. Now, unfortunately, the word average actually means any measure of central tendency. So the fact that it's a mean is not really prescriptive in that. It's just the one that people tend to default to. So for instance, a median is another way of finding an average. And I will do this when I do my grades as well. Median is the idea of listing all of your values from smallest to largest, whatever they are, and choosing the one in the middle. Okay. Kind of gives you a benchmark and say, oh, well, half the whatever is this where. It's like from Hugging Grade. Half the class did better than me. Yeah, the average was a 72, but half the class got A's and B's. Right? That kind of an idea. It gives you another perspective on what's going on in a particular situation. Now, it has this weird sort of thing, because what happens is if you put numbers in order, sometimes there's actually a number in the middle, and sometimes there are two numbers in the middle. So if there's actually a number in the middle, that will happen when you have an odd number of values. Okay, so if you have an odd number of values, you actually get a little number. If you have an even number of values, like we would happen to do if we put all the numbers of values tests in this class, and there's 6 of you, I'm going to have two numbers that sort of both fall in the middle. So I take both of those two numbers and I would average them. I'd add those two together and divide by 2. So it kind of ends up mixing this idea of mean with this idea of middle value because there's two numbers. The third one is mode. Mode would be a really common idea. So let's say you were talking about a company of somebody who does, let's say for instance, contractors. So let's say that you have a contractor and he's got all the people who work for him and they do, carpentry, they do the plumbing, they do the electrical work, and they do the painting, and they do the installing, and they do the cleaning of the house when it's ready for the homeowner to be done, or whatever. You've got all these people who work for the contractor. If you want to know what on average the salary is in that company, you probably want to look at sort of where most of the values are. I don't really care how much the contractor makes, right? We're really more thinking about what all the people who work underneath him make. So when you're looking at mode, you're simply looking for the number that occurs most frequently. So if you sort of put these different contractors, subcontractors, or workers into different categories, you say, oh, it looks like the majority of them make about $30,000 a year. Well, that makes more sense, but if you actually added all their salaries together, including the contractor, and you divided by however many of them there were, you might find out the number is more closely related to the number of 50,000. Again, great salaries working there. Something's a little bit off when you do that. So there are cases when the mode makes the most sense as well. That's the number that occurs most frequently. We're going to do an example. We have it's like 7 numbers here. We're going to find the mean, the median, and the mode. Okay? So how do I find the mean? Remind me. Yes. And you have to show me one of two things. Okay? You either have to show me 18 plus 22 plus 22 plus 17 plus 30 plus 18 plus 12 over 7. Or it's okay with me if you just put all that in your calculator. So somebody tell me what the numerator and the add all together. Add the 18, 22, 22, 17, 30, 18, and 12. 139. I didn't have it written down, so I'm going to take your word for it, Sarah. 139. So you either have to show me this piece on the left, or you have to show me this part right here. You got to show me one of these. I don't care which one it is necessarily, just show me one of them. And then your final answer as well. And what is 139 divided by 7? We're going to go with 1 decimal backwards here in this section, okay? 1 decimal is enough. the average in terms of the mean for the 7 numbers is 19.9. This kind of looks like ACT scores to me. Certainly in that ballpark. All right, median now. So what I do when I have to do median is you have to show me that you've done this. You actually have to list the numbers from smallest to largest. There's nothing else you can do, okay? So what's my smallest number? 12. And then, good, and then 2 18s, 2 22s, and a 30. And you sort of count your ways. It isn't difficult so much on this one, but however big your values are, you count your ways inwards, right? So as you move from the outside in, we somehow managed to find out that on this particular one, there's only one value in the middle, and it is an 18. So the median here is actually 18. The mean was 19.9. And then the last one is mode. Mode, which one occurs most frequently? Yes, and you said it exactly right, Hannah. Whether you were unsure of it or not, you're correct. There's actually 2 modes here. We call that bimodal. You know, kind of like bipolar. Bimodal. There's 2 modes. And so however many occur most frequently, you can have multimodal, so that's okay. And if you have none of them occurring more than once, that's no mode application. All right? Let's see what I have next here. Makes sense to say something or not. All right, we'll do one more because it goes with mean, meaning, mode, and mean along. I'm sorry, one more slide, and then we'll stop. Example 2. The mean score on a set of 20 tests is a 75. What is the sum of the 20 test scores? Okay, like what?
The way that you get to 75 is something divided by 20%.
And that something is actually the sum of the scores, isn't it? Yeah. So the way that I found, for instance, let me flip back to my other slide, the way that I found the mean is that I took the sum of all my values and I divided it by the number of values. And that's not exactly a formula per se, we could write it so it were, but it is, and that's what we did. That's the form that we followed. So if I have the sum divided by 20 is 75, how am I going to find out what the sum is? Yeah, I'm just going to multiply this 20 in essence on both sides, so I don't have the 20 on the left and I do have it on the right. And what is 75 times 20? 1,500. So the sum would have been 1,500. And here's an application more than just a language choice of how to do that, of that kind of idea. If the mean weight of 7 linesmen on a team in football is 230 pounds, and the mean weight of the 4 backfield members is 190 pounds, what is the mean weight of the 11-person team? And if you've ever watched College Football Vacation, they'll start talking in this sort of second about how big the line is, or something like this. This is what they're talking about. They're talking about the weight, or sometimes the height, depends on the description of what they're talking about. But they're talking about something like this, okay? They're looking at the average weight or the average height of specific members on the team. So in this case, we've got 7 of them that have an average of 230 pounds. We have 4 of them that have an average of 190 pounds. How are we going to find the average of all 11? What I really end up doing is I take their average times how many of them there are. So the average weight for the linesman is 230, and there are 7 linesmen. And I take the average weight of the backfield members, which is 190, and I take the number that there are, and this is 4. Add those and I divide by 11. As long as you show me this much, you can do the rest in your calculator. What does your calculator say? Again, 1 decimal of accuracy. Right? Oh, I don't know what happened there, but that's interesting. 215.5 pounds would be the average or the mean weight of the 11 person team. Another caveat to this, you've seen this before, whether you first and coalition or this at all. Have you ever been in an elevator, and the elevator lists 2 things? They tell you the maximum number of people are supposed to be on the elevator, and they tell you the maximum weight. Okay? So I don't know about you, but there have been occasions where I've been somewhere where it's an elevator, you look around and people in the elevator and you're thinking, there's more people than there's supposed to be, or you very quickly start to think, but do we exceed the weight? The weight's the more issue here, really, right? This is what's going on, right? So when they post that in the elevator, they're doing some sort of an average. They're saying, oh, the average person weighs X amount, whatever the number is, they about 150 pounds or whatever. And if I multiply that by, this number of people, say I have 10 people, this weight, this number of people could be supported by this elevator. But it's an estimation thing, right? So if I have a bunch of little kids in the elevator, I'm good to go, 30 kids in the